So welcome to our video on a few example problems having to do with some random triangles and how we're going to use the law of sines to find missing sides and angles. So as I'm working these examples here, you're going to write down the work on the sheet that I passed out in class yesterday, and go ahead and use these examples to help you solve the sheet of 8 problems that I also gave you yesterday. So here we go. In example 1, I've got parallelogram ABCD. I'm going to find side CD here and angle ABD. ABD, so that would be this angle here. So I'm going to call this angle X, and then I'm going to notice that because this is a parallelogram, one of the properties of parallelograms is that these opposite angles are congruent because of their symmetry, making this angle also 24 degrees. All right, so now what I'm going to strategize is what do I need to do to get to side CD and angle X. So the first thing I'm noticing is that I've got a 17 here, which is one side of this triangle, and a 12 here, which is another side. So, and I've got an opposite angle and side pair here. So I could use law of sines to find this angle here in this triangle, which is opposite this known side, and see if that would help me. So if I find this angle, now let's look at this line right here. So these are parallel lines because this is a parallelogram, so we can consider this a transversal. So if two parallel lines are cut by a transversal, alternate interior angles are congruent, so that helps us. This angle is also angle X. All right, so now if I go back to my original thinking here, here's a pair, angle side pair. Then I can set up this angle side pair and use law of sines to find angle X. So that would look like sine of 24 over 12 is equal to sine of X over 17. So that would mean 12 sine of X is equal to 17 sine of 24. Sine of X is equal to 17 sine 24 divided by 12. So typing that into the calculator and taking the inverse sine of that, you should get X is equal to 35.184 degrees. All right, so angle X is the angle I'm looking for because that's angle ABD. All right, so angle ABD, I'm going to put it over here, is equal to 35.2 rounded to the 10th place. All right, now we need to find CD, and then we'll be finished. So let's think about how we can do that. All right, so let me just call this D for short instead of CD. So I need to find this side over here, so that's part of this triangle again. So if I was going to use the law of sines, I could use this same ratio here, but I would need this angle to do my other pair here. So if I know angle X is 35.184 and 24 is angle C, let's call it, then I can say 180 minus 24 minus 35.184 is equal to, so that's 120.816. All right, so that's the angle across from, that's this angle here, 120.816. All right, now we can say sine of 24 over 12, use that one again, is going to be equal to sine 120.816 over little d. All right, so that should get it. So d sine 24, 12 sine 120.816, dividing 816 sine 24. Okay, just typing all of that in, that becomes 25,338. All right, so I did that calculation there to find that little d side. Now I'm going to write it over here. This is CD, rounding to the 10th place. That's my answer. So here's our next example. We're going to find AD and AB. So I'm going to call AD little d for short, and I'm going to call AB little c for short. So I'm going to find those two dimensions there. So looking at my picture, I'm going to come up with a strategy here. So I've got this right triangle here, and then I've got this larger right triangle, and then I've got this oblique triangle here. So I have three triangles to consider. All right, so now when you've got these kind of nested triangle problems, you need to go where you've got a side dimension, because just having angles isn't going to get you anywhere. So the only side I'm given is 12. So somehow I've got to work my 12 through this triangle setup and figure out what this is and what this is. Now the way I like to think about it is there's got to be a connector piece to connect the one with the triangle here, which contains the only side dimension I've got, to the triangle over here, which has these values C and D that I'm trying to solve for. So what I mean by that is this side X is shared by both this triangle here and this triangle here. So if I can find this X, then I could jump on over into this triangle. All right. So in order to find this X, I got to think about something that I can do. So this is the hypotenuse of this right triangle. So I've got that 35-degree angle there, which would make this the opposite, this the adjacent, and the X would be the hypotenuse of that right triangle. So I can say, if I'm working with adjacent where my number is 12, and X where my hypotenuse is, that's adjacent and hypotenuse. I could say the cosine of 35 is equal to 12 over X. So that would mean X cosine 35 is equal to 12, or X is equal to 12 divided by the cosine of 35. So if I type that into the calculator, I get that X is equal to 14.649. All right, so that'll help me bridge on over to this other triangle that I'm interested in. All right, so if I have this side now, which is my only side dimension I have. Let's see if I can set up law of sines. I would need to have this angle here. So what I can see now is that this angle and this angle are supplements, which means 180 minus 35. 180 minus 35, that's 145. This angle here is 145. All right, so now I've got an angle opposite side C. So that'll help me find side C, but I need the angle opposite side X. Well, that is a triangle, so 180 minus 145 minus 22 should give me that remaining angle. So that's 13. Okay, so this angle we know now. All right, so that's enough information to figure out what I have over there in the second triangle. So first, let's say sine of 13 over x. We said x was 14,649 is equal to, let's solve for d first, sine of 22 over little d. So that's d sine 13 equals 14,649 sine 22. So this is a divide, 14,649 sine 22 divided by sine of 13. So little d, I'm getting 24.395. Okay, so one more calculation. I need side C. So I can say again, sine of 13 over 14.649. So I'm solving for side C, so that would be opposite angle to C is 145 over C. So C sine 13 equals 14,649 sine 145. C is 14,649 sine 145 divided by sine 13. So typing that into the calculator, I'm getting 37.353. All right, so now let me just write it out. My answer, because I'm looking for AD and AB. So AD, AB. So AD is little d. I'm going to round that to the tenths place. And AB is little c. So that's 37.4. And this is what I'm looking for here. And then I'm done. So our last example here, it says find x and AC. So x is this dotted line here, perpendicular to this 95 side, and also AC. So I'm just calling this side B here. All right. Now let's see what I can do here. So I need a strategy. So if I'm going to find x, I can see that this is one side of this right triangle, but it's also one side of this right triangle. All right, so if I were to be able to find it at this point, I have an angle here, but I have no side. I only have this whole side over here. Same situation over here. I have an angle, but I have no side with which to set up a trig ratio to find x. All right, so if I'm going to find x, I somehow need to use this only side that I'm given to get some of these other sides in here so I can figure out x. All right, so what I do see is if I've got this 40 here, then this must be 90 minus 40, which is 50. That's easy to calculate. And if this is 30, then this other acute angle must be 90 minus 30, which would be 60. So that would give me the angle opposite 95, which would be helpful because that would allow me to set up the law of sines. So 50 plus 60 is 110 degrees. So that angle is 110 degrees opposite side, the 95 side. All right. So I could say sine of 110 over 95. Now let's see. If I were to find B, I could look at this big triangle and say that ratio would equal sine of 30 over B. So let's write that out. Sine of 110 over 95 should equal sine of 30 over little b. All right, that will work. So b sine 110 equals 95 sine 30. B is 95 sine 30 divided by sine 110. All right, so that comes out to, if I type it into the calculator, 50.548. All right, so now I can use, since I have this side now, which is the hypotenuse of this right triangle, I can set up a trig ratio to find x here, because I've got an angle, I've got this angle and this angle, so I could use x as my opposite and b as my hypotenuse, of course, and I could say the sine of the angle 40 is equal to the opposite side, x, over the hypotenuse, which is b, which we now have a number for. So we have x is equal to 50.548 sine of 40, which comes out to be 32.492. All right, so that's your x side, which is one of the things we wanted. And then the other thing we wanted was AC, which is b. So we now know AC is 50.5, so that's rounded to the tens place. All right, so we've answered that question as well. So these are just a few examples of how you can use right triangle trig in combination with the law of sines. We didn't need the law of cosines in these examples, but that could come up as well. So in combination, we were able to come up with the strategies to find these missing parts of these triangle problems. All right, so now your job is to go ahead and do the 8 word problems on the worksheet that we received on Thursday. And if you weren't in class on Thursday, you would go to Canvas and look up Thursday's assignment and just write it on notebook paper. And if you're virtual at the moment, you would just go ahead and create a PDF and email it to me so I can receive your work. All right? So email me or send me a message on Remind if you have any questions about the homework. Otherwise, our assignment is due on Monday. I will talk to you later.